Hello students, welcome all of you. In this video, I Abhay Kumar going to discuss a very important topic in physical optics, chapter diffraction of light, which is Fraunhofer's diffraction due to a single slit for B.Sc Part 2 Physics courses. In lecture number 14 of physical optics. Suppose AB be a single slit of width small d, a parallel beam of light coming from an extended monochromatic light source fall normally on the single slit AB. According to Huygens principle, each point of the single slit AB will send secondary wavelets traveling normal to the slit are focused by a convex lens L on the center O of the screen Y by 1, where secondary wavelets, that is at the center O of the screen, will meet in the same phase. So point O of point O, that is center of the screen Y by 1, will be the position of central maximum or central maxima. Another pairs of secondary wavelets diffracted through angle theta by the single slit are focused by the lens L at another point P of the screen Y by 1. We have to find the resultant intensity of light at point P. For this, we have to obtain path difference between the diffracted light waves from point A and B of the slit, and then corresponding phase difference. The path difference between two diffracted rays, that is two diffracted light waves, two diffracted secondary light wavelets at point A and B of the slit, is given by B.Sc. B.Sc is the extra distance covered by the light ray secondary wavelet producing from point B of the slit, and this extra distance B.Sc is the path difference between two secondary light wavelets diffracted at point A and point B of the single slit, and this distance B.Sc is given by E into sine theta, E into a small e into sine theta, because in the right angle triangle we have drawn a perpendicular AC on BC or BP, so that this angle BAC is a theta. So sine theta equals to perpendicular BC upon hypotenuse AB, and hypotenuse AB is the width of the single slit, which is given by which we have taken a small e. Therefore, sine theta is equal to BC perpendicular upon hypotenuse AB. Therefore, BC is equal to AB sin theta, and AB we have taken a small e, width of the slit. So BC part difference is equal to, BC is the path difference between two diffracted light waves, that is secondary light waves, light wavelets, path difference between two diffracted light waves from points A and B of the slit equals to BC. BC ही पार्ट डिफरेंस होगा, यह एक्स्ट्रा डिस्टेंस स्लिट के का पॉइंट बी से प्रोड्यूस होने वाला सेकेंडरी लाइट वेवलेट BC एक्स्ट्रा डिस्टेंस कवर करता है. तो दिस इज द पार्ट डिफरेंस बिटवीन ए से पी का डिस्टेंस, मतलब ए से प्रोड्यूस होने वाला जो सेकेंडरी लाइट वेवलेट है या लाइट वेव है, तो वह जब स्क्रीन पी पर फोकस होगा विद द हेल्प ऑफ लेंस सेल एंड सी के आगे AC परपेंडिकुलर ड्रॉ किया गया है BC पर या BP पर, तो A से P का डिस्टेंस एंड C से P का डिस्टेंस इक्वल है. तो एक्स्ट्रा डिस्टेंस जो सेकेंडरी वेवलेट बी पॉइंट से सिंगल स्लिट के बी पॉइंट से प्रोड्यूस होता है, तो वह एक्स्ट्रा डिस्टेंस BC कवर करेगा, जो कि पार्ट डिफरेंस है बिटवीन टू डिफ्रैक्टेड लाइट वेव्स डिफ्रैक्टेड एट point A and B of the single slit. So it is path difference between two diffracted light waves from point A and B of the slit is equal to BC is the extra distance BC, and BC is equal to AB into sin theta, that is a small e into sin theta, where a small e is the, suppose it is equation 1, and the small e is the width of the slit, width of the single slit AB, width, where a small e equals to width of the single slit AB. Now corresponding phase difference between two diffracted light waves from point A and B of the slit is given by phi, and write down, and the corresponding path difference के corresponding phase difference is equal to 2 pi by lambda into multiplied by path difference. So the corresponding phase difference between two diffracted light waves is phi equals to 2 pi by lambda into path difference, that is 2 pi by lambda, and path difference is a small e sin theta. Now we can divide the single slit AB into n equal parts. The amplitude of vibration at point P, because secondary wavelets are reaching at another point P of the screen diffracted through angle theta from the single slit. So we can suppose single slit AB of width small e, single slit AB की चौड़ाई कितनी है, small e है, तो इसे n इक्वल पार्ट्स में हम डिवाइड कर सकते हैं. We can suppose the width of the slit, that is AB is equal to a small e, can be divided into equal parts, and the amplitude of vibration at point P due to the waves from each part will be the same. Amplitude of vibration जिसे ऑब्जर्व किया जाएगा पॉइंट पी स्क्रीन y/1 के पॉइंट पी पर, तो इस पार्ट के वेव के कारण इस पार्ट से प्रोड्यूस होने वाले सेकेंडरी वेव जो पी पॉइंट पर पहुंचेगा, तो उसके कारण जो वाइब्रेशन होगा उसका एम्पलीट्यूड सेम होगा, एंड लेट दैट एम्पलीट्यूड is equal to a small e. That is amplitude of vibration at point P due to the waves from each point of the slit AB will be the same, and say it is equal to a small a. So the phase difference between the wave from any two consecutive parts of the slit will be 1 by n times the total phase difference phi. And so write down phase difference between the waves, that is secondary wavelets producing from any two consecutive parts of the slit AB, and it is equal to phi upon n, that is 1 by n multiplied by phi. Phi is the phase difference between the secondary wavelets producing from point A and B of the slit. तो सिंगल स्लिट के किसी दो लगातार पार्ट से प्रोड्यूस होने वाले लाइट वेव्स के बीच जो फेज डिफरेंस होगा, अगर हम सिंगल स्लिट को n इक्वल पार्ट्स में डिवाइड करते हैं तो एनी टू कंसेक्यूटिव पार्ट्स सिंगल स्लिट के एनी टू कंसेक्यूटिव पार्ट्स से प्रोड्यूस होने वाला लाइट वेव्स के बीच में फेज डिफरेंस कितना हो जाएगा, ए बी इक्वल टू टोटल जो फेज डिफरेंस है फाई, उसका 1 by n पार्ट हो जाएगा, तो 1 by n मल्टीप्लाइड बाई फाई, दैट इज 1 by n, एंड फाई इज गिवन फेज डिफरेंस बिटवीन द लाइट वेव प्रोड्यूसिंग फ्रॉम secondary light waves producing from point A and B of the slit is 2 pi by lambda into E sin theta. So it is 1 by n into 2 pi by lambda into a small e sin theta. And suppose it is equal to D, this phase difference between any two consecutive parts, phase difference between the light waves producing from any two consecutive parts of the single slit is 1 by n multiplied by 2 pi by lambda into E sin theta, and suppose it is equation number. Say this phase difference equal to a small d, and it is equation number 3. Now resultant amplitude at point P of the screen will be given by, write down the resultant amplitude at point P of the screen is given by capital R is equal to A sin nd upon 2 upon divided by, it is A sin nd upon 2 divided by, it is a small a we have taken the amplitude of light wave producing from each part of the slit when we divide single slit AB into n equal parts. तो each part से प्रोड्यूस होने वाले सेकेंडरी वेवलेट का amplitude small a है. So resultant amplitude at point P is given by A sin nd upon 2, nd upon small n small d upon 2 upon sin d by 2 sin d upon 2, and say it is equation number 4. Now substituting the value of d, small d, which we have taken a small d is equal to 1 by n multiplied by 2 pi by lambda into e sin theta. So substituting the value of a small d, which is the phase difference between the secondary light waves producing from any two consecutive parts of the slit, which is a small d. That phase difference is a small d, which is equal to 1 by n multiplied by 2 pi by lambda into a small e sin theta. तो उसका वैल्यू अगर पुट कर दिया जाए इस इक्वेशन में तो हम ऑब्टेन करेंगे r का वैल्यू इक्वल टू देन वी कैन ऑब्टेन r इक्वल टू a sin alpha अपॉन sin alpha by n, where pi e sin theta upon lambda, we can suppose it as alpha, that is direction of the maxima. So pi by lambda into e sin theta, suppose pi by lambda e sin theta, let suppose it to be alpha. So resultant amplitude now, which is a small a sin nd upon 2 upon sin d by 2. Now substituting, suppose it is equation 4, and substituting the value of d, that is phase difference between the light waves producing from any two consecutive parts of the slit. We have taken it 1 by n multiplied by 2 pi by lambda into e sin theta, and we have taken it a small d. So substituting and pi by lambda into e sin theta, suppose it is alpha, that is direction of the maxima, and minima. So we can obtain, we have to use this value of that is the value of small d in equation 4, and suppose pi by lambda e sin theta equals to alpha. The resultant amplitude at point P of the string, we obtain a sin alpha upon sin alpha by n. So we have the resultant amplitude of light meeting at point P of the screen y by 1 is a small a sin alpha upon sin alpha by n. Since alpha by n is a small, so we can take sin alpha by n as alpha n, but here it is a sin alpha upon sin alpha by n using equation 3, that is substituting the value of a small d, which is the phase difference between two light waves between the secondary light wavelets producing from any two successive parts of the slit AB. So substituting the value of d from equation 3 and equation 4, we can obtain capital R equals to a sin alpha upon sin alpha by n, where we have taken pi by lambda into e sin theta equals to alpha, which is the angle, that is direction of maxima and minima. Alpha represents the direction of maxima and minima. Since alpha by n is small, we have divided the single slit AB into n equal parts. So number of parts is if number of parts will be very large, then alpha by n will be a small. So for a small value of theta, we can write sin alpha by n is equal to sin only alpha by n. Therefore, R equals to a sin alpha upon alpha by n equals to n, a small n ऊपर चला जाएगा न्यूमरेटर में, n is multiplied in the numerator, so n a sin alpha upon alpha, and let n into a is the amplitude of the light wave producing from each part of the slit. So n is the total number of parts of the slit. So n into a is the total amplitude of all secondary light waves producing from the entire slit. So we can write in place of Na, we can substitute. We can put in place of Na a small n into a small n into a small a as capital A, that is amplitude, total amplitude, resultant amplitude of the light waves or secondary light wavelets produced from the entire slit AB. Therefore, resultant amplitude R. This is the final expression for resultant amplitude. Therefore, resultant amplitude of the light waves meeting at point P after diffracted through angle theta from the single slit. So, resultant amplitude of light, entire light waves at point P is capital R equals to capital A sin alpha upon alpha, and suppose it is equation number 5, where we have taken a small n into a small a is equal to capital A, that is total amplitude of the light. Where n, a small n into a small a equals to a. See. Fraunhofer diffraction at a single slit में सिंगल स्लिट एक सपोज किया गया है ए बी, जिसका विड्थ स्मॉल ई है, और पैरेलल बीम ऑफ लाइट किसी एक्सटेंडेड मोनोक्रोमेटिक लाइट सोर्स से, क्योंकि फ्राउनहोफर डिफ्रैक्शन में स्लिट से या ऑब्स्टेकल से लाइट सोर्स एंड स्क्रीन दोनों इनफाइनाइट डिस्टेंस पर होता है, सिचुएटेड होता है, इसलिए लाइट सोर्स स्लिट ए बी से लार्ज डिस्टेंस पर है. सो द लाइट सोर्स इज, द सोर्स ऑफ लाइट इज एक्सटेंडेड and source of light is also monochromatic, that is which emits wavelength of single wavelength of light. तो लाइट सोर्स मोनोक्रोमेटिक लाइट सोर्स है जो कि सिंगल वेवलेंथ को प्रोड्यूस करता है, और उससे प्रोड्यूस होने वाला लाइट वेव्स को जो पैरेलल बीम ऑफ लाइट है जो लार्ज डिस्टेंस से आ रहा है मोनोक्रोमेटिक लाइट सोर्स से, वह पैरेलल बीम ऑफ लाइट सिंगल स्लिट ए बी के नॉर्मली मतलब ए बी के परपेंडिकुलर इंसिडेंट होता है. एंड हाइजेंस प्रिंसिपल से जब प्लेन वेव फ्रंट पैरेलल बीम्स ऑफ लाइट जब स्लिट ए बी पर इंसिडेंट होगा, तो उस सिचुएशन में प्लेन वेव फ्रंट सिंगल स्लिट ए बी पर इंसिडेंट होगा, क्योंकि जब लाइट सोर्स इनफाइनाइट डिस्टेंस पर होता है, वेरी लार्ज डिस्टेंस पर होता है, तो उसका वेव फ्रंट कैसा होता है, उसका वेव फ्रंट प्लेन होता है. तो जब प्लेन वेव फ्रंट सिंगल स्लिट ए बी जिसका विड्थ हमने सपोज किया है स्मॉल ई, तो उस पर इंसिडेंट होगा, तो सिंगल स्लिट के एवरी पॉइंट से, क्योंकि वहां पर सिंगल स्लिट पर प्लेन वेव फ्रंट इंसिडेंट हुआ है, तो सिंगल स्लिट ए बी का ईच पॉइंट सेकेंडरी सोर्स जैसा बिहेव करेगा, और वह एक न्यू लाइट वेव को, जहां से एक न्यू लाइट वेव प्रोड्यूस होगा इस सोर्स से, तो ईच पॉइंट ऑफ द सेकेंडरी सिंगल स्लिट ए बी का ईच पॉइंट ऑफ सेकेंडरी सोर्स जैसा बिहेव करेगा, और वह एक न्यू लाइट सोर्स को वह एक न्यू माने ईच पॉइंट जो है सेकेंडरी सोर्स जैसा बिहेव करेगा, एंड ईच पॉइंट ऑफ द स्लिट विल प्रोड्यूस ए न्यू लाइट वेव विच इज नोन एज सेकेंडरी वेवलेट. तो सिंगल स्लिट ए बी के परपेंडिकुलर डायरेक्शन में ए बी के पॉइंट ए एंड बी से प्रोड्यूस होने वाला सेकेंडरी वेवलेट, जो कि स्लिट के नॉर्मल डायरेक्शन में परपेंडिकुलर डायरेक्शन में ट्रेवल करेगा, वह सेम फेज में जाकर स्क्रीन Y1 के सेंटर ओ पर जाकर मीट करेगा, with the help of a convex lens L, and therefore सेम फेज में, क्योंकि सिंगल स्लिट के पॉइंट ए एंड पॉइंट बी से प्रोड्यूस होने वाला सेकेंडरी लाइट वेवलेट्स सेम फेज में मीट करेगा सेंटर पर, स्क्रीन के सेंटर ओ पर, इसलिए स्क्रीन का सेंटर ओ का जो पोजीशन होगा वह मैक्सिमा होगा और उसको सेंटर मैक्सिमम कहा जाता है। जबकि सिंगल स्लिट ए बी के पॉइंट ए एंड बी से या इसके अलावा अंदर ए एंड बी के अंदर अदर पॉइंट से भी थीटा एंगल पर डिफ्रैक्ट होने वाला लाइट रे, ओरिजिनल डायरेक्शन से थीटा एंगल से डिफ्रैक्ट होने वाला, थीटा एंगल से बेंड हो जाने वाला लाइट वेवलेट्स, वह फोकस किया जाता है लेंस के द्वारा स्क्रीन y/1 के एक अनदर पॉइंट P पर, जहां हम लोगों को रिजल्टेंट एम्पलीट्यूड मालूम करना है। और जो हमने रिजल्टेंट एम्पलीट्यूड यहाँ पॉइंट P पर, स्क्रीन के पॉइंट P पर मालूम किया, कितना किया, कैपिटल R इक्वल टू A sin अल्फा अपॉन अल्फा। So this is the resultant amplitude which we obtain at point P, which is another point of the screen y/1 besides the central point O of the screen. Central point O is the position of maxima, which is called central maxima. स्क्रीन के सेंटर, स्क्रीन y/1 का जो सेंटर वो है वह मैक्सिमा का पोजीशन है। वहां पर ब्राइटनेस होगा, मतलब वह जो पोजीशन है वो वहां पर ब्राइटनेस होगा, वहां पर उस ब्राइट माने कहने का मतलब है वहां लाइट की इंटेंसिटी बहुत ज्यादा होगी स्क्रीन के सेंटर ऊपर, और उस पोजीशन को सेंट्रल मैक्सिमा कहा जाता है। और उसके अराउंड, मतलब सेंट्रल मैक्सिमा के ऊपर एंड नीचे, मतलब सेंट्रल मैक्सिमा के दोनों साइड्स में अल्टरनेट डार्क एंड ब्राइट फ्रिंजेज ऑब्टेन होगा, जिसकी इंटेंसिटी सेंट्रल मैक्सिमा का जो पोजीशन है वो उससे डिस्टेंस बढ़ने पर दोनों साइड में जो अल्टरनेट मिनिमा एंड मैक्सिमा ऑब्टेन होगा, जिसे सब्सिडियरी मिनिमा और सेकेंडरी मिनिमा और सब्सिडियरी मैक्सिमा और सेकेंडरी मैक्सिमा कहा जाता है। तो उसकी इंटेंसिटी, लाइट की इंटेंसिटी जैसे जैसे हम दूर जाएंगे वो से ओ के दोनों साइड्स में तो घटती जाएगी, और अंत में काफ़ी अधिक डिस्टेंस पर, सेंट्रल पॉइंट ओ से अधिक बहुत लार्ज डिस्टेंस पर लाइट की इंटेंसिटी नियरली 0 हो जाएगी। लेकिन वो जो पोजीशन है वो पर जो है वो मतलब स्क्रीन का पोजीशन हो, वहाँ लाइट की इंटेंसिटी बहुत अधिक होगी। इंटेंसिटी ऑफ लाइट विल बी मैक्सिमम एट द सेंटर O of the screen y/1. So that position O of the screen is known as the position of central maxima. So the resultant amplitude at point P, which is another point P is another point on the screen where the resultant amplitude of light waves is given by capital R equals to A sin alpha upon alpha, and suppose it is equation number 5. Now intensity of light, resultant intensity of light at point P of the screen is given by I is equal to k r square. I varies since intensity of light is directly proportional to a square of the amplitude, and so it is I varies as capital R square. Resultant intensity of light at point P, suppose it is just capital I, is directly proportional to capital R square, and we can write it as I is equal to k into R square, where k is a constant of proportionality. But for simplicity, for convenience, we can take the value of constant of proportionality, k is equal to 1. So we can write the resultant intensity of light at point P of the screen. Point P पर लाइट का रिजल्टेंट इंटेंसिटी को अब एक्सप्रेस किया जा सकता है, रिजल्टेंट इंटेंसिटी of light at point P point P of the screen y by 1 is a equals to k into r square. K is the constant of proportionality. K का value suppose k is equal to 1 for convenience. So it is a is equal to amplitude is equal to resultant intensity I equals to it is equal to I. Amplitude is capital R we have taken. Or intensity of light, resultant intensity of light at point P I varies as r square, amplitude square. Therefore I is equal to k r square. And taking k is equal to 1, constant of proportionality for convenience, it is I equals to r square, and it is r equals to given in final expression of the resultant intensity of light at point P is given by equation 5, which is a sin alpha upon alpha. So it is I is equal to r square, intensity of resultant intensity of light at point P. I is equal to r square, and r is a sin alpha by alpha. So it is a into sin alpha upon alpha का whole square, और sin square alpha upon alpha square. So a square into I is equal to r square. Therefore it is a square. R का वैल्यू सब्स्टिट्यूट किया जाए, इसमें रखा जाए a sin alpha by alpha. Therefore a square sin square alpha by alpha square, that is a square multiplied by sin alpha upon alpha का whole square. And suppose it is equation number now it is equation number 6, which is the expression for the resultant intensity at point P of the screen. Now we have to obtain the direction of maxima and minima or condition of maxima और मिनिमा एट पॉइंट पी. तो हमें अल्फा का वैल्यू ऑब्टेन करना है, और जिससे कि कंडीशन ऑफ मैक्सिमा दैट इज डायरेक्शन ऑफ मैक्सिमा, अल्फा का वैल्यू ऑब्टेन करना है जिससे कि कंडीशन ऑफ मैक्सिमा एंड मिनिमा को ऑब्टेन किया जा सके. तो फॉर फर्स्ट ऑफ ऑल वी हैव टू फाइंड द डायरेक्शन ऑफ मिनिमा और कंडीशन ऑफ मिनिमा. तो मिनिमा के लिए क्या होगा, इंटेंसिटी ऑफ लाइट 0. तो आई इक्वल टू 0 कब होगा, जब आई इक्वल टू 0 होगा मिनिमम इंटेंसिटी. तो उस सिचुएशन में कब होगा 0, जब साइन अल्फा बाई अल्फा इक्वल टू 0. So write down direction and condition, directions and conditions of maxima and minima. So first of all, direction of minima. For direction of minima, intensity of light should be 0 and I is equal to 0 when intensity of light will be 0. Minimum intensity, minimum means क्या हो, लाइट की इंटेंसिटी वहाँ मिनिमम हो जाए, वहाँ कम, वहाँ क्या होगा, डार्कनेस हो जाए. डिफ्रैक्शन के केस में तो ज्योमेट्रिकल साइडों में भी थोड़ा डिफ्रैक्शन के कारण थोड़ा सा लाइट दिखाई देता है, लाइट प्रेजेंट होता है. लेकिन इंटरफेरेंस के केस में तो मिनिमा के केस में जब इंटेंसिटी ऑफ लाइट 0 होगी तो वहाँ पर कंप्लीट डार्कनेस होता है, टोटली वहाँ अंधेरा होता है, पूरा अंधेरा. तो I इक्वल टू 0 बिकॉज मिनिमम इंटेंसिटी, position of point will be minima if intensity of light will be 0, and intensity of light will be 0 then when from this equation intensity of light, from this equation, that is equation number 6, intensity of light will be 0 if sin alpha by alpha will be equal to 0. So I is equal to 0 when sin alpha upon alpha is equal to 0. In equation 5, for minima intensity of light I is equal to 0 when sin alpha upon alpha will be equal to 0. Therefore that means sin alpha is equal to 0. That means sin alpha is equal to 0 और अल्फा is equal to plus minus m pi, जो जनरल वैल्यू है. So we have in equation 6, it is intensity of light I is equal to a square multiplied by sin alpha upon alpha to the whole square. And equation 5, the resultant amplitude at point P of the screen it was given by r equals to a sin alpha upon alpha. So from in equation 6 for minimum intensity of light at point P will be minimum if when that is I is equal to 0, when sin alpha by alpha is equal to 0, or sin alpha equals to 0, that is alpha equals to plus minus m pi, where m having integral values except m is equal to 0. मिनिमा के लिए m is equal to 0 नहीं होगा, क्योंकि मैक्सिमा के केस में m is equal to 0 होगा. मैक्सिमा के केस में क्योंकि सेंट्रल का जो पोजीशन है वह मिनिमा नहीं है, मैक्सिमा. तो यहाँ पर m का सभी ऑल इंटीग्रल वैल्यूज होगा, जिसकी हेल्प से हम डायरेक्शन ऑफ मिनिमा, फर्स्ट मिनिमा, सेकेंड मिनिमा, थर्ड मिनिमा, सब्सिडियरी मिनिमा का डायरेक्शन हम ऑब्टेन कर सकते हैं विथ द हेल्प ऑफ दिस इक्वेशन. एंड इट इज अल्फा इज इक्वल टू प्लस माइनस m pi if sin alpha is equal to 0, then suppose it is equation number 7, and m having all integral values except 0, so m is equal to 1, 2, 3 and so on. Putting m is equal to 1, we will obtain the condition of first subsidiary minima, but value of alpha is given. We have already obtained, we have already used the value of alpha, that is we have taken pi e sin theta upon pi e sin theta upon lambda as alpha. So in place of alpha we can write pi e sin theta upon lambda. We have already used it, that is for the direction alpha, pi small e sin theta upon lambda, we have taken alpha. So in place of alpha we can write pi e sin theta upon lambda equals to plus minus m pi. If theta is small, then sin theta we can write sin theta as theta. Pi and pi both sides will cancel out. So the condition of minima we have obtained in the case of diffraction at a single slit is e sin theta equals to plus minus m into lambda. लैम्डा यहाँ मल्टीप्लाई हो जाएगा क्रॉस मल्टीप्लिकेशन से. एंड दिस इज द कंडीशन ऑफ मिनिमा इन द केस ऑफ Fraunhofer diffraction at a single slit. And we can take for first minima, first subsidiary or secondary minima, we have to put m is equal to 1, and for a small value of theta, sin theta is equal to theta. So we can write this equation, the condition of minima. Write down, this is the condition of minima in Fraunhofer diffraction at a single slit. And if theta is small, then sin theta is equal to theta. So the direction of minima can be given by this equation. Taking sin theta is equal to theta, we have theta is equal to plus minus m into lambda upon e, that is theta m is equal to plus minus m lambda upon e. Theta means theta m, where m is an integer, m having all integral values except m is equal to 0. So theta is equal to theta m is equal to plus minus m lambda upon e. If we take m is equal to 1, then it is the direction of first subsidiary or secondary minima on the either side of the central maxima. Central maxima m का वैल्यू 1 पुट किया जाएगा, तो सेंट्रल मैक्सिमा का जो पोजीशन है स्क्रीन पर हो, उसके दोनों साइड में फर्स्ट सेकेंडरी मैक्सिमा का डायरेक्शन ऑब्टेन होगा. जब थीटा इक्वल टू जब m इक्वल टू 2 रखेंगे तो दैट इज थीटा 2 मीन्स द डायरेक्शन ऑफ सेकेंड subsidiary minima, that is plus minus 2 lambda by e. If we put m is equal to 3, then we obtain the direction of third minima, that is theta 3 is equal to plus minus 3 lambda by e, plus 3 lambda by e वह स्क्रीन का सेंटर के ऊपर होगा, एंड माइनस 3 लैम्डा बाई ई वह डायरेक्शन होगा थर्ड सेकेंडरी मिनिमा का, जो कि सेंटर स्क्रीन का सेंटर होके नीचे होगा अकॉर्डिंग टू द कन्वेंशन. So we can obtain the direction of secondary minima on the either side of central maxima by the relation theta is equal to theta m is equal to plus minus m lambda upon e, and suppose it is equation number 9, where m having values, all integral values 1, 2, 3 and so on except 0, because 0 is the position of m is equal to 0 is the position of central maxima. सेंटर पर स्कीम के सेंटर पर मिनिमा का पोजीशन नहीं है, सेंट्रल मैक्सिमा का पोजीशन है. नाउ वी हैव टू ऑब्टेन द डायरेक्शन ऑफ मैक्सिमा. To find the direction of maximum intensity at point P of the screen, we have to differentiate the equation of intensity which was given in equation 6 in this video, and that equation 6 was I is equal to capital A square. I is the intensity, resultant intensity of light at point P. I is equal to capital A square sin alpha upon alpha ka whole square. So to find the direction of maximum intensity at point P, differentiating equation 5 with respect to alpha, and then equating it to 0. That is because we know for maxima or minima dy by dx is equal to 0. So now we have to obtain the direction of maxima. So differentiating equation for direction of maxima, to obtain the direction of maxima, differentiating equation 6, that is I is equal to a square sin alpha upon alpha square with respect to alpha, and then equating is equal to 0. Now write down that for direction of maxima. For direction of maxima, we have di, differentiating equation 6 with respect to alpha and then equating to 0, or we can write d upon d alpha, and value of I is given by equation 6 as a square multiplied by sin alpha upon alpha square, and it is equal to 0. Now differentiating a square sin alpha upon alpha square with respect to alpha, we have a square is a constant, so it is, or we have a square is constant, so it is taken out of the differentiation, symbol d upon d alpha, and it is differentiation of d by d alpha of sin alpha by alpha square is 2 sin alpha upon alpha, 2 into sin alpha upon alpha multiplied by, now dc of sin alpha by alpha, then it is denominator square, that is alpha square, and now in the numerator, denominator is constant, that is alpha multiplied by differentiation of numerator, that is numerator is sin alpha, denominator is alpha. So differentiation of sin alpha is cos alpha. Alpha is constant, denominator is constant in the first term. So differentiation of sin alpha is cos alpha minus now numerator is constant, that is sin alpha, and dc of denominator, that is d by d alpha of alpha is 1, so it is 1, so it is only sin alpha into 1, that is sin alpha. So we have and it is equal to 0. It is equal to 0, and thus we can obtain the direction of maxima, that is now alpha into a square, 2a square sin alpha by alpha cannot be equal to 0, but the product of these terms is equal to 0. Therefore the bracketed term must be will certainly equal to 0. So we have alpha, therefore we have alpha cos alpha minus sin alpha upon alpha square equals to 0, or alpha cos alpha minus sin alpha equals to 0, or alpha cos alpha equals to sin alpha, taking sin alpha into RHS, it is minus sin alpha in LHS, so in RHS it will be sin alpha. LHS में sin alpha के पहले नेगेटिव साइन है, तो sin alpha को RHS में ले जाने पर sin alpha पॉजिटिव हो जाएगा, तो alpha cos alpha इक्वल टू sin alpha, therefore alpha इक्वल टू sin alpha by cos alpha, that is tan alpha. Therefore alpha equals to sin alpha upon cos alpha equal to tan alpha. So the result is alpha equals to tan alpha. We have obtained it. Alpha equal to tan alpha for the direction of maxima in case of Fraunhofer's diffraction at a single slit. And suppose it is equation number. Now equation 9. Suppose it is equation number 9. And this equation is solved graphically, which we have done in figure 2 in plot of y versus alpha. So this equation, that is y by tan, y equal to tan, alpha equal to tan alpha given by equation 9, can be solved graphically by plotting the curves, two curves. One is a straight line, y equal to alpha, passing through the origin, having unit gradient m is equal to 1. So if gradient m is equal to 1, m is tan theta, therefore theta will be 45 degree. That is slope of this straight line passing through the origin, having unit slope, that is m is equal to tan theta, and if m is equal to 1, then theta is equal to tan theta is equal to 1, means theta is equal to 45 degree. तो इस लाइन का इक्वेशन 45 डिग्री होगा. सो इक्वेशन 9, सो राइट डाउन इक्वेशन 9 which is alpha is equal to tan alpha for the direction of maxima. It can be solved graphically by plotting the curves y is equal to alpha and y is equal to tan alpha. So equation 9. So equation 9, that is alpha is equal to tan alpha, can be solved graphically, which we have represented in the plot of y versus alpha in figure 2. Graphically, by taking two curves or by taking two equations, that is by taking two curves or two equations, y is equal to alpha, say it is equation number 10, and also y is equal to tan alpha, say it is equation number 11. The intersection of two, that is y is equal to alpha, which is a straight line, and y is equal to tan alpha is a discontinuous curve, similar to the graph of y is equal to tan x. तो y is equal to tan alpha का जो ग्राफ है वह tan x का ग्राफ के टेंजेंट का ग्राफ के सिमिलर है, जो कि एक डिसकंटिन्यूअस कर्व है, एंड और इसमें हैविंग ए नंबर ऑफ ब्रांचेज, इसमें कई ब्रांचेज हैं. तो द पॉइंट्स ऑफ इंटरसेक्शन ऑफ द स्ट्रेट लाइन, दैट इज स्ट्रेट लाइन रिप्रेजेंटेड बाय द इक्वेशन y is equal to mx होता है. तो यहाँ पर स्लोप कितना है लाइन का, 1 है. y is equal to alpha is the direction of maxima here, and slope is 1, means this straight line y is equal to represented by y is equal to alpha passing through the origin in figure 2 makes angle 45 degree to the x-axis, along which the direction of maxima is plotted, which is alpha. Along x-axis there is alpha, direction of maxima, and along y-axis it is y, a small y. So the straight line y is equal to alpha is passing through the origin, and the graph of y is equal to tan alpha given by equation 1 is represented by a discontinuous curve similar to the graph of tangent. So the point of intersection of these two, that is y is equal to alpha and y is equal to tan alpha, gives the direction of maxima. Gives the directions, different values of डायरेक्शन ऑफ मैक्सिमा, डिफरेंट वैल्यूज ऑफ अल्फा. कहाँ से मिलेगा? पॉइंट ऑफ इंटरसेक्शन दोनों का, स्ट्रेट लाइन का y इक्वल टू अल्फा का, और दूसरा जो है y इक्वल टू tan अल्फा, जो डिसकंटिन्यूअस कर्व है y इक्वल टू tan अल्फा, जिसका ग्राफ tan x के जैसा है. तो इन दोनों का पॉइंट ऑफ इंटरसेक्शन दो जगह हमने सपोज दिखाया है, रिप्रेजेंट किया है इस ग्राफ में. एट टू पोजिशंस वी हैव प्लॉटेड इन द प्लॉट ऑफ y वर्सेस अल्फा. There are two positions we have plotted in this graph, and there are two positions where, that is between pi by 2 and 3 pi by 2, and between 3 pi by 2 and 5 pi by 2. There are two positions in this graph we have represented so far. There are two positions where the straight line y is equal to alpha given by equation 10, and the curve y is equal to tan alpha intersect, and these positions, these points where the two curves are meet together will give the values of alpha, and value of alpha which we have already taken pi e sin theta upon lambda. We have already taken it as alpha. So we will obtain the direction of maxima. Different values of direction of maxima from the point of intersection of two curves, and it will give the values of various maxima, intensity of various maxima. So, and these values are approximately, that is values of alpha are approximately the values of alpha. Now the values of alpha are found to be approximately alpha is equal to, first value is alpha is equal to alpha is equal to 0, that is at the origin, where both curves, one a straight line and second is y is equal to tan alpha, intersect at origin also. So alpha is equal to 0. Another position near alpha is equal to 3 pi by 2. Approximately at 3 pi by 2, both a straight line y is equal to alpha and y is equal to curve y is equal to tan alpha intersects, which is indicated in this plot of y versus alpha given in figure 2. So another value is, first value is alpha, where both a straight line y is equal to alpha and this curve y is equal to tan alpha intersect. That position will be, that point will give the direction of maxima. So it is, first value is 0, second value is approximately equal to 3 pi by 2. So it is 3 pi by 2. Then approximately equal to 5 pi by 2. Value of direction of maxima is 5 pi by 2. Net value will be 7 pi by 2, and so on. Putting these values of alpha in the expression for intensity, we have already obtained I equals to a square sin alpha upon alpha square, that is equation number 6. So putting, if we put alpha is equal to 0 in that equation number 6, we can obtain I0 is equal to a square upon sin 0 by 0 the whole square, that is a square. So substituting these values in equation 6, that is the expression for resultant intensity of light at point P of the screen. So substituting These values of alpha means direction of maxima. These alpha gives the direction of values of alpha at the point of intersections. At the point of intersection of two equations, y is equal to alpha and y is equal to tan alpha, will give the direction of maxima. So substituting these values of alpha in equation number 6, that is the expression for resultant intensity of light, A is equal to I is equal to A square multiplied by sin alpha upon alpha square. We get I0 for alpha is equal to 0, which is I0 equals to, which is the position of central maximum, which is the intensity of the central maximum. Intensity of the central maximum is I0 is equal to A square multiplied by sin 0 upon 0 square, that is A square. So intensity of central maximum is A square. Intensity of central maximum. Now putting alpha is equal to 3 pi by 2 in equation number 6, and we will get the intensity of first subsidiary or secondary maxima. So we have I1 is equal to, putting alpha is equal to 3 pi by 2, we have now I1 is equal to A square multiplied by sin 3 pi by 2, alpha is 3 pi by 2 upon 3 pi by 2 square. Sin 3 pi by 2 is 1, so 3 pi by 2 square, that is 9 pi square upon 4, so it will be 4 upon 9 pi square, that is A square multiplied by 4 upon 9 pi square. I1, if we put alpha is equal to 3 pi by 2 in equation 6, that is equation of maximum intensity, resultant intensity at point P of the screen, we get the intensity of first subsidiary or secondary maxima. ये हो गया पोजीशन इंटेंसिटी ऑफ I1 इज द इंटेंसिटी ऑफ फर्स्ट subsidiary or secondary minima, and it is A square upon 9, A square multiplied by 4 upon A square multiplied by 4 upon 9 A square. Sorry, A square upon multiplied by 4 upon 9 pi square, and after substituting the value of pi square 9.86, value of pi square, substituting the value of pi square as 9.86, we can obtain approximately as after calculation A square upon 22. So I1 is equal to, I1 will nearly equal to A square upon 22. Where we put the value of alpha, that is direction of maxima, as 5 pi by 2, we will obtain the intensity of second secondary maxima, and it will be I2 is equal to A square under bracket sin 5 pi by 2 square upon 5 by 2 का whole square, 5 by sin 5 pi by 2 is equal to 1, and 5 pi by 2 square is 25 pi square by 4, that will be equal to 4 upon 25 into A square, and it will approximately equal to A square by 61 after substituting the value of pi square as 9.86. So putting alpha is equal to 5 pi by 2, another point of intersection of two curves, another position of point of intersection of two curves, that is alpha is equal, y is equal to alpha and y is equal to tan alpha. So we will get putting alpha equals to 5 pi by 2. After 3 pi by 2, we have to put 5 pi by 2. we have I2 equals to, we will obtain I2 is equal to 4 upon 25 multiplied by a square. After putting alpha is equal to pi by 2 in equation number 6, that is the expression for the resultant intensity of light at point P, we will obtain I2 is equal to 4 upon 25 multiplied by a square, and it will be approximately equal to 4 upon 25 a square, and it will be, after substituting the value of pi square, is equal to 9.86. It is I2 is equal to, that is intensity of secondary maxima or second subsidiary maxima. I2 is equal to 4 by 25 into a square. Capital A is the resultant amplitude of light meeting at point P of the screen. कैपिटल ए रिजल्टेंट एम्पलीट्यूड है लाइट का, जो मीट करते हैं कहाँ, पॉइंट पी, लाइट वेवलेट्स जहाँ मीट करते हैं पॉइंट पी स्क्रीन का, जो अनदर पॉइंट स्क्रीन का है, तो वहाँ पर पॉइंट पी पर लाइट का रिजल्टेंट एम्पलीट्यूड है, एंड अप्रॉक्सीमेटली इट इज इक्वल टू ए स्क्वायर, मतलब 4/25 ए स्क्वायर, 4/25 पाई स्क्वायर, सॉरी 4/25 पाई स्क्वायर a square is approximately equal to a square upon 61. After taking the value of pi square, after substituting the value of pi square as 9.86 in it, 4 upon 2, I2 is equal to 4 upon 25 pi square into a square. It is the intensity of secondary maxima at point P. Putting the value of alpha is equal to 5 by 2 in the equation 6, that is equation of resultant intensity of light at point P. I is equal to a square multiplied by sin alpha upon alpha square. So it is a square by 61. And similarly, if we can obtain the value of I3, that is the intensity of third subsidiary maxima at point P, as a square by 121. After putting alpha is equal to 7 pi by 2 in equation 6, that is the expression for resultant intensity of light, I is equal to a square multiplied by sin alpha by alpha square. We will obtain I3 is equal to a square upon 121. Therefore, and so on. Thus, the intensity of successive maxima are in the ratio of, we can find the ratio of, we can obtain the ratio of successive maxima in case of the Fraunhofer diffraction at a single slit, as so the ratio of इसका रेशियो होगा successive intensities of the successive maxima, the ratio of intensities of successive maxima as I1 ratio I2 ratio I3 ratio I4 ratio ... so on is equal to, we can obtain it. So it is I0, first is I0, then I1, I2, I3, I4 and so on. I0 is only a square, which is the intensity of central maxima, and so it is 1 upon, and next is I1 is a square by 21, it is a square by 21 nearly equal to a square multiplied by 4 upon 9 pi square is nearly equal to a square by 21. So we have I0 ratio I1 ratio I2 ratio I3 a square ratio a square by 21 ratio a square upon 61, next a square upon 121. So we will get I square will cancel out. So it is the ratio 1 upon 1 by 21, ratio 1 upon, that is I2 is 1 upon 61, because it is a square by 61. इसको रेशियो लिया जा रहा है, तो ए स्क्वायर सभी से कैंसिल हो जाएगा, ऑल टर्म्स में कॉमन होगा, तो इसलिए एंड I3 का वैल्यू हम ऑब्टेन कर सकते हैं, पोजीशन ऑफ थर्ड, दैट इज इंटेंसिटी ऑफ थर्ड subsidiary maxima as a square upon 121. So it is after putting alpha is equal to 7 pi by 2 in 7 pi by 2 in equation number 6. So it is 1 upon 121. Now the direction of most of the incident light is concentrated in the principal maxima. जैसा कि मैंने बताया कि principal maxima जहाँ पर स्क्रीन का सेंटर है ऊपर, वह पोजीशन मैक्सिमम मतलब वह मैक्सिमम इंटेंसिटी का पोजीशन होगा लाइट का, तो वहाँ लाइट की इंटेंसिटी मैक्सिमम होगी, तो इंसिडेंट लाइट जो होता है कंसंट्रेटेड होता है, मोस्ट ऑफ द इंसिडेंट लाइट इज कंसंट्रेटेड इन द प्रिंसिपल मैक्सिमा विच अकर्स इन द डायरेक्शन गिवन बाय प्रिंसिपल मैक्सिमा का के लिए डायरेक्शन क्या होता है, अल्फा इज इक्वल टू 0, दैट इज अल्फा वैल्यू ऑफ अल्फा इज पाई ई साइन थीटा अपॉन लैम्डा इज इक्वल टू 0, दैट इज थीटा बराबर 0, दैट इज in the same direction as the incident light. Most of the incident light is concentrated in the principal maxima which occurs in the direction. So since the direction of maximum alpha is given by alpha is equal to 0 and alpha we have taken pi e sin theta by d is equal to 0, therefore theta is equal to angle of diffraction theta is equal to 0, that is in the same direction. If theta is 0, which is the direction as that is the diffracted light will be travel along the direction of incident light as we have seen it in figure 1, that at position point O, that is center of the screen, the diffracted light from the single slit travels along the direction of incident light and meet in the same phase at the center of the screen. Therefore the position of maximum intensity of light is observed at point O of the screen. That is, if theta is equal to 0, if alpha is equal to 0, then theta is equal to 0. That is in the same direction as the incident light angle of diffraction is. Therefore, the secondary wavelets after diffraction from the single slit AB, if travel along the same direction of the incident light, then point O of the screen, that is the center of the screen, will be the position of central maxima. Now we can plot the intensity distribution of intensity pattern of diffraction, Fraunhofer diffraction at a single slit, that is variation of intensity of light with diffraction angle theta, and which will be the final graph in case of Fraunhofer's diffraction at a single slit. We can plot it taking intensity of light along y-axis and direction, that is angle of diffraction, along x-axis, and it is the intensity of light is along, it is I intensity of light along y-axis, and the intensity of light is maximum at the center of the screen is O, and surrounded by and both sides of the center of the screen there will be the position of alternate minima, that is subsidiary or secondary minima and maxima. The intensity of secondary maxima will be continuously decreasing as we go beyond the center of the, on both sides of the center of the screen. So this is plus theta, that is along right to the center of O of the screen, that is theta is plus angle of diffraction, that is direction of maxima and minima are representing together along positive x-axis and negative x-axis also. So this is along negative x-axis, it is minus theta, along positive x-axis it is plus theta, along y-axis along plus y axis it is intensity of light, and at point O, that is at the central maxima, intensity of light is maximum. So the peak of this plot is maximum at this intensity of light is I naught, maximum intensity. That is I0 is the maximum intensity of light corresponding to the center O of the screen, that is the position of secondary maxima. So the intensity of light is maximum, and both sides of the secondary maximum we will obtain alternate subsidiary minima and maxima. The intensity of maxima will be continuously decreasing as we go beyond the center of the screen, either sides of the center of the screen. We can see it in this plot, and position of maxima and minima will also obtain along the negative x-axis, that is along the which represents the direction of maxima and minima below the center of the screen. So in left side of the center O, that is position of central maxima. O is the position of central maxima where intensity of light is maximum, which is represented in this graph. This is the position of minima, first subsidiary minima or first secondary minima on left side of the center of the screen also, and then followed by first secondary maxima on the either side of the central maxima, and then intensity of secondary maxima will be smaller than that of the first secondary maxima. Then position of third secondary maxima will also smaller than that of the secondary maxima, and intensity of light will be continuously decreasing as we go beyond the center of the screen. Center of screen से जैसे जैसे दूर जाएंगे दोनों साइड्स में, पॉजिटिव एक्सिस के लॉन्ग, नेगेटिव एक्सिस के लॉन्ग, कहने का मतलब है कि सेंटर के स्क्रीन का सेंट्रल पॉइंट ओ के ऊपर, स्क्रीन का सेंटर तो सेंट्रल मैक्सिमम का पोजीशन है, तो उससे ऊपर जाएं या उसके नीचे जाएं स्क्रीन में, वो पॉइंट के नीचे, तो वो पॉइंट के नीचे जो पोजीशन है माइनस एक्सिस के लॉन्ग, एंड सेंटर स्क्रीन का सेंटर के ओ के पॉइंट के ऊपर का जो पोजीशन है वो है लॉन्ग प्लस एक्सिस के लॉन्ग डायरेक्शन को, मैक्सिमम मिनिमा के डायरेक्शन को रिप्रेजेंट किया गया है. तो दोनों साइड में जाने पर सेंटर पर तो इंटेंसिटी लाइट की मैक्सिमम होगी, लेकिन दोनों साइड में जाने पर जब हम स्क्रीन के ऊपर जाए, स्क्रीन का सेंटर वो के ऊपर जाए या नीचे जाए, लाइट की इंटेंसिटी घटेगी और मैंने सेकेंडरी मैक्सिमा की इंटेंसिटी घटेगी. तो अल्टरनेट हमें क्या ऑप्शन हुआ, सेंटर पर, स्क्रीन के सेंटर पर, दैट इज डिफ्रैक्शन एट ए सिंगल स्लिट के केस में सेंटर पर क्या हो गया, मैक्सिमम इंटेंसिटी I0 ऑब्जर्व हुआ, और सेंटर के दोनों साइड में ये फर्स्ट सेकेंडरी मैक्सिमा मिनिमा का पोजीशन है जो कि प्लस लेमडा, इसका वैल्यू कितना होगा, इसका वैल्यू के लिए मैंने कंडीशन ऑब्टेन किया था, थीटा m इक्वल टू प्लस माइनस लेमडा अपॉन ई इज द विड्थ ऑफ द स्लिट AB and lambda is the wavelength of light. So plus lambda by E, this position of first secondary minima, and either according to left of this center point O or central maxima, it is the position of first secondary minima, position of first secondary or subsidiary minima, and then it is the position of first secondary maxima, and then followed by the position of secondary or subsidiary minima, whose direction is given by plus 2 lambda by E, and along negative x-axis, that is below the center of the screen, it is position of second, that is direction of second subsidiary minima is minus 2 lambda by E, putting m is equal to 2. Then again we get the secondary position of second secondary maxima whose intensity is smaller than that of the first secondary maxima on the either sides of the central maxima, that is on the either side of the center of the screen. And similarly the position when then we again obtain the position of third subsidiary minima whose position is left to the center of the screen or below the center of the screen or below the central maximum. It is minus 3 lambda by E followed by minus 4 lambda by E and so on, and along the positive direction, that is along right to the central maxima, that is right to the center or above the center of the screen in the experiment figure 1. The position of third secondary position of the third secondary or subsidiary minima is given by plus 3 lambda by E followed by plus 4 lambda by E, that is position of the fourth secondary minima. Thus we get the diffraction pattern, that is which represents the variation of intensity of light about the central maxima with direction of change in angle, that is with the direction of maxima and minima. Variation of intensity light with the direction of maxima and minima, which is taken along positive x-axis and minus negative x-axis, that is plus. Along positive axis it is direction of maxima and minima represented by the symbol plus theta, and along the negative x-axis, that is below the screen, so below the center of a screen, it is direction of maxima and minima is represented by symbol minus theta. So this represents figure 3, that is total figure 3 of this video, and this is the diffraction pattern of diffraction, Fraunhofer diffraction at a single slit, which represents the variation of intensity of light with direction of maxima and minima. That is I theta plot. This is I theta plot, intensity of light and angle of, that is direction, angle of diffraction plot हो गया. I theta plot means represents the, that is diffraction pattern. This is the diffraction pattern, variation of intensity of light with the direction of maxima and minima or with the diffraction angle. So this is I theta plot, means diffraction pattern due to diffraction of light, Fraunhofer diffraction due to a single slit, due to Fraunhofer diffraction at a single slit, due to Fraunhofer diffraction at a single slit, Now this video is completed after the diffraction pattern of due to Fraunhofer diffraction at a single slit, in which variation of intensity of light about central maxima with direction of maxima and minima, that is theta, plus theta and minus theta, it is represented in this plot which is shown in figure 3. This video is now this video is completed. In the next video we will discuss another case of diffraction, Fraunhofer diffraction, but due to n parallel slits, that is plane transmission grating. In case of plane transmission grating, in a plane transmission grating there are n equidistant parallel slits. So very important topic. In the next video also we will discuss that is Fraunhofer diffraction at n parallel slits, but in the next video. And this topic is also very important topic for the examination point of view, that is Fraunhofer diffraction at a single slit for B.Sc Part 2 physics courses, that is for physics honors, B.Sc Part 2 physics honors, B.Sc Part 2 physics subsidiary, and also for B.Sc Part 2 general courses. This topic, that is Fraunhofer diffraction of light at a single slit is very, very important for the examination point of view. Thanks all of you for watching my YouTube channel, Physics Quantum Classes.